Welcome back, everybody. Today we're going to look at linear inequalities. Linear inequalities, we also used to look at them as alligator symbols. We solve them the way we would solve regular linear equations. The only difference is we have a solution set that involves more answers, and we graph that on a number line. Remember to change the direction of the inequality symbol when you multiply or divide by a negative number. And we're going to learn how to write our solution in interval and set notation. Let's start with our first example. If number 1 was a regular equation with an equal sign, then we would say, okay, I need to get x alone. I'm going to start with the opposite of adding 5 is subtracting 5. So we have negative 3x. The 5's add to 0. Negative 7 minus 5 more is negative 12. Our last step to get x alone, this is negative 3 times x. The opposite is dividing by negative 3. Negative 3 divided by negative 3 is 1x. And negative 12 divided by negative 3 is 4. What changes is now we have this inequality. So we still solve everything the same way. It's just that we pay attention to the fact that when I get to the point where we're dividing by negative 3, we're dividing by a negative. So the sign reverses, and our answer is x is less than 4. What that means on a number line is that we have 4, and because it's not equal to, we would have an open circle. We would go to the left, everything that's less than 4. All right, in interval notation, what that looks like is we take the left side, which is negative infinity that it's heading to, and the right side, which is 4. And because it's not equal to, we put parentheses around it. Let's try this with example 2. So we have negative 2x plus 7 is less than negative 5. Again, same steps as if that was an equal sign. So I would start with subtracting 7 from both sides. We have negative 2x, negative 7 and 7 add to 0. We don't change the sign, the inequality sign, because we're subtracting. It stays the same. Negative 5 minus 7 more is negative 12. We finish getting x alone. The opposite of multiplying by negative 2 is dividing by negative 2. So negative 2 divided by negative 2 is 1x. This time we divided by a negative. So our inequality sign does change directions. And negative 12 divided by negative 2 is positive 6. So if we're graphing this on a number line, we again have an open circle at 6 because this is not equal to, and the numbers greater than 6 are over here to the right. If we're using interval notation, we use the 6, and then over here on the right side we have positive infinity. This is not equal to, so we put parentheses around it. Let's talk a little bit more about this interval notation. So we're reviewing graphing these on a number line with open circles if it's greater than or less than, closed circles if it's got the equal to. If we're talking about interval notation, we use parentheses if it's not equal to, which we were just talking about. Brackets means it was equal to. So if we had x is greater than or equal to 2 as an answer, then we'd have bracket 2 and infinity. Infinity symbols always have parentheses, always. All right, we don't know what infinity is, so we can't say something equals infinity if we don't know what infinity means. That's why infinity has a parenthesis. Set notation, interval notation. We talked about this way back in one of the first sections that we took notes on, and that is x such that x. So x such that x is greater than 2 is set notation. Because this is not equal to, we have a parenthesis here at 2. Remember, infinity always gets a parenthesis. And this graph would look like this. X such that 2 is less than x is less than 5. Again, these are not equal to. Our left side is 2, our right side is 5, and they have parentheses. On a graph, this would be an open circle at 2, an open circle at 5, and shading in between. X such that x is less than 5. Less than is negative infinity, so interval notation, negative infinity to 5. Again, there's no equal to here, so the 5 has a parenthesis. Infinity always gets parentheses. This would be an open circle at 5, going to the left. X such that x is greater than or equal to 2. This gets a bracket because it's equal to. And then it goes to positive infinity because there's no stopping point here. Infinity always gets a parenthesis. So this would be a closed circle in this direction. X such that 2 is less than x is less than or equal to 5. So we're going to start looking at our graphs a little bit different. I just wanted to review what we used to use. So now on our graphs, whatever we have for our interval notation is what's going to go on our graph. So we're looking at this one, and it goes from 2 to 5. So we have a parenthesis at 2 because that was not equal to, and a bracket at 5 because it was equal to, and x was in the middle, so we're shading in the middle. Now we're going to flip-flop that around. 2 is less than or equal to x means we have a bracket, and then less than 5 means we have a parenthesis because it's not equal to. So bracket at 2, parenthesis at 5, and x was in the middle over here, so we shade in the middle on our graph. x such that x is less than or equal to 5. Again, we're going to negative infinity with that. So we have negative infinity to 5. Infinity always gets a parenthesis. 5 gets a bracket. So we have a bracket at 5. And then we're going with the arrow because of infinity. 2 is less than or equal to x is less than or equal to 5. Those are both brackets because they're both equal to. So bracket at 2, bracket at 5. X is in the middle, so we shade in the middle. Going back and reviewing a little bit of an OR problem here. So we have x is less than or equal to 2, or x is greater than 5. I'm sorry, x is less than 2, or x is greater than 5. So less than 2 means we're going to negative infinity. There's no stopping point on the left side of x. So we have parentheses negative infinity, and the 2 gets a parenthesis because it's not equal to. And then or means a union. Or means a union. X is greater than 5. So we're starting at 5. 5 gets a parenthesis because it's not equal to. And then there's no stopping point. So that's positive infinity. So on a graph, parenthesis at 2, shading to negative infinity. Parenthesis at 5, shading to positive infinity. So let's try this in action. We have this inequality, we're solving for x. So I'm going to start with getting my x variables together. I'm going to add 3x, add 3x. 4 is less than or equal to 7 plus 5x. Subtract 7. Okay, we subtracted, we didn't divide, so we don't have to change our inequality sign. 4 minus 7 is negative 3. And then we finish by dividing by 5. Now we divided by a positive 5, so negative 3/5, and the inequality again does not change. Well, I don't really like having my x on the right, so I want to change it. Well, we can do that and say x is greater than or equal to negative 3/5. So if we go back to our alligators, in this right here, the alligator wants to eat x. When we rewrote it, the alligator is still eating the x. So we didn't change anything, we just visually made the x go on the left side. If we were writing this in set notation, we'd have x such that x is greater than or equal to negative 3/5. If we're writing it in interval notation, greater than negative 3/5 means we're starting at negative 3/5 and going to infinity. Because it's equal to, negative 3/5 gets a bracket, and then infinity always gets a parenthesis. And then to graph that, we have a bracket at negative 3/5, shading to the right for positive infinity. Let's try number 2. I again want to get my x values together, and I think I'm again going to go ahead and move that 4x over to the right. So we have 3. That adds to 0 is greater than or equal to 2 plus 4 is 6. So we have 6x plus 8. I'm going to subtract 8. We have negative 5 is greater than or equal to 6x. Divide both sides by 6, and we have negative 5/6 is greater than or equal to x. Again, I don't really care for the x being on the right, so we can pick it up and flip it over as long as we keep the direction of the inequality the same. So again, over here, the alligator is eating the negative 5/6, or saying that the 5/6 is the bigger value, and we've kept that the same way over here when we rewrote it. Writing that in set notation, x such that x is less than or equal to negative 5/6. That's our set notation. Interval notation, less than 5/6 means we're going to negative infinity. Remember, infinities always get parentheses. We're stopping at negative 5/6, and this is equal to. So that's a bracket. Putting that on a number line, 0, -1, -2. Negative 5/6 is going to be over here close to 1, and we're shading to the left for negative infinity. A break-even point. A break-even point is the point where the profit or revenue, R, and the cost, C, have the same value at the same number of units sold. So if we have a revenue equation at 4x and a cost equation at 2x plus 11, determine the break-even point. Well, remember, we always want our revenue to be more than the cost. So if I were going to write this as an inequality, we would write 4x must be greater than or equal to. Remember, if it's equal to, then they'll at least break even, 2x plus 1,000. So we're going to subtract the 2x over to its like term. 4 minus 2 is 2x is greater than or equal to, these two x's add to 0, 1,000. Divide by 2. I'm dividing by a positive so I don't change the direction of my inequality. And so we have x is greater than or equal to 500. In set notation, that's going to be x such that x is greater than or equal to 500. In interval notation, 500 is our starting point, and it's equal to, so that we get a bracket, and it's going to infinity because it's more than 500, which gets a parenthesis. So how would we answer this question? Well, we would say this company must sell at least 500 units or product to break even. The last part of our notes for this section are to talk about the three-part inequalities. We called these AND problems in previous courses. So basically what's happening is we have two equations squished together into one. So I'm going to show you two different ways to do this. If you don't mind seeing this all put together, then we're taking the middle and getting x alone. So we have 5 and 3. I got to start by moving the 5. That's a positive 5, so the opposite would be subtracting 5. Not only do I have to subtract 5 from over to the 20, But we also have to subtract 5 from the negative 2 because remember, we had two equations and we squished them together into one. Negative 2 minus 5 more is negative 7. We're subtracting, so nothing changes with these inequality symbols. Those 5's add to 0, so we have 3x, and then 20 minus 5 is 15. Our last step is to divide everything by 3. And so we have negative 7/3 is less than, that reduces to 1, x is less than 5. So our left side is negative 7/3. It gets a parenthesis because the inequality sign is not equal to. And the right side, we're stopping at 5. That also gets a parenthesis because it's not equal to. And 7/3 is roughly 2 1/3. So 1, 2, 3, 4, 5. We would have a parenthesis there, a parenthesis here, and the x is squished in between those, so it's shaded in the middle. Let's look at a different way to solve this. Let's say that looking and doing all of that together at once doesn't really work for us. Instead, I'm going to separate this into two separate problems. So in our first problem, we have 1 is less than or equal to 6x minus 8. In our second problem, we have 6x minus 8 is less than 4. Solving for x on the left problem, we're adding 8. We get 9. 6x, the 8's add to 0. Divide by 6 on both sides. We're going to reduce that to 3/2 is less than or equal to x. On the right side, add 8 to both sides. So we have 6x is less than 12. Divide by 6, and we have x is less than 2. Now we can bring these equations together because this x and this x are the same, so we want to overlap them. And when I drag this over, the 3/2 drags over, the x's overlap, and 2. In set notation, this would be x such that positive 3/2 is less than or equal to x is less than 2. In interval notation, the 3/2 is equal to, so it gets a bracket. The 2 is not equal to, so it gets a parenthesis. Three halves is 1.5. So we're going there. 2 is a parenthesis. The x is squished, so the shading gets squished in the middle. And that's all we have today for section 1.7. Have a great night. We'll see you next time.